Hi everyone, welcome to AutoVerse Academy. We are automotive training service providers, and today in this video, we will be trying to understand what is AutoVerse certified professional and how can you become one, and what are the various topics will be covered under this particular program, right? Um, the reason we have this curated program is today we understand there is a tremendous demand in terms of automotive software professionals who have a knowledge of topics like CAN, AUTOSAR, LIN, FlexRay, Ethernet. So these are the basics topics anyone who is working in the automotive industry should be aware of, right? And we are trying to have all of these topics combined as a one package course, and anybody who takes up these programs and clears this program, they will be called as a AutoVerse certified professionals, right? So the program does not only concentrate on delivering the training or completing the training. The key focus would be to ensure that proper knowledge transfer is done, and all the trainees clear the evaluation test. And once they do that, we actually call them AutoVerse certified professionals. And the key USP of this program is it's not going to be a complete theoretical session. The focus would be given on hands-on, where we will have a 40% of a theoretical coverage and a 60% of a hands-on training, right? So this hands-on would give an exposure to a real-time work environment, real-time industry exercises, where individual get a confidence how to handle a particular tool options, or how do they build a particular product out of using this technology concept and tools. Yeah. And also this program is only limited to 30 members, so that participant gets the full attention during this entire training, so that they can clarify their doubt, and they can be very confident once they complete the training. Okay, so we'll go to the course outline and try to see how the course outline looks like or the course schedule looks like. Okay, then coming to the program schedule itself, the program schedule is designed in a such a way that it will not disturb a working professional with their work. So they can, anybody who is a working professional who can take this training alongside their work. So majority of the training would happen on weekend, and there will also be a short session of 2 hours or 4 hours on the weekdays, so that we have a continuous engagement, and the people who kind of learn on the weekend go back and try some exercises, or they want to revise, right? They can always come back on these weekday 2 hours or 4 hour session, where we can discuss and clarify their doubt, and also cover some of the topics on the weekdays as well. Okay, then coming to the program schedule itself, the program schedule is designed in a such a way that it will not disturb a working professional with their work. So they can, anybody who is a working professional who can take this training alongside their work. So majority of the training would happen on weekend, and there will also be a short session of 2 hours or 4 hours on the weekdays, so that we have a continuous engagement, and the people who kind of learn on the weekend go back and try some exercises, or they want to revise, right? They can always come back on these weekday 2 hours or 4 hour session, where we can discuss and clarify their doubt, and also cover some of the topics on the weekdays as well. Okay, so if you look at this schedule, the first module what we are targeting here is the CAN TP, CAN FD, and the CAN protocol itself, right? So we are going to spend 4 days on this topic, starting from 23rd April and will end by 28th of April, right? So we'll be spending 6 hours of sessions on the weekend and 2 hours of 2 sessions on the weekdays. Okay, so the next module we will have is a LIN FlexRay Automotive Ethernet. Okay, maybe before we go to that one, maybe I'll quickly show you what is the content of CAN TP and CAN FD, so you are familiar with those details. So coming back to Okay, coming to the detailed course outline. So here you can see what all the content we'll be covering in CAN TP, and CAN FD. Okay, so coming to the CAN, so we are going to start with very basics, where we'll try to understand what is the standard, how it is implemented, what is the node architecture, what is the bus connection, what are the different voltage levels corresponding to different bit levels, and what is the basic principle on which CAN protocol is built, like CSMA, CD, and NDBA are the two basic principles, and what is the benefit of using this particular network, and when we compare this network with other protocols or the other networks, how does it stands, what are the similarities, what are the differences, right? And we'll also try to understand what is a protocol converter, a bus separator, or a gateway, and what its role when we talk about a hybrid network or a in-vehicle networking. We'll then go to the CAN transceiver, CAN controller, and CAN bus part, which is the three predominant parts of the CAN protocol. When we'll try to understand how does they interact with each other, what is the physical line between a CAN controller and a CAN transceiver, and how does the CAN bus looks like, what are the different logic level, what is the communication principle, right? What kind of coding format is used here, right? Why do we need a termination resistance? What is this twisted pair of wires, how they are helping to reduce the noise? So all of this information would be discussed in the second topic. This third one will try to understand the characteristics of a CAN protocol, which also includes the frame format of both standard and extended, and we'll try to understand the bus arbitration, the addressing mechanism, right? Different types of frames, what we have in the CAN, the data frame, remote frame, right? The error frame, overload frame, and what is the importance of this bit stuffing, CRC, acknowledgement, right? And how does the error detection happens in the CAN protocol? How do we treat and come out of a so-called bus off state, right? So all of this would be discussed in the characteristics of a CAN protocol. Then we come to the CAN FD, where more major focus is to understand how does this CAN FD trying to compete with all the other protocols, because CAN FD is something which has come after CAN. It is an extension of CAN protocol. So here we are mainly talking about the flexible data rate, right? So we can go up to maximum of 10 Mbps, and how that can be achieved, right? And how we can send more than 8 bytes of data without doing a multi-frame concept. So all of this would be discussed inside a CAN FD protocol. Coming to the CAN TP. So in the CAN TP, the idea is to use the CAN protocol and send more than 8 bytes of a data, where we discuss about a single frame, first frame, flow control frame, and consecutive frame. So using all these 4 frames, how can we transmit a 4 kilobytes of data, right? Using this 8 bytes repeatedly. And also we'll try to understand what is block size, what is estimate timing parameter, right? So, and we'll also try to achieve this by doing a hands-on session where we write a code either on a C program or on a CAPL, and where we try to create a 2 nodes and exchange the information, right? So in that way, the CAN FD, and the CAN TP, we can try to understand, code it, execute it, and get a feel of how the communication happens. Okay, so that's about the CAN protocol course outline. Okay, now coming back to the second topic, what is mentioned here, which we will be covering on day 5 and day 6. Now, the second topic is mainly for advanced communication protocol, which is more like a LIN, FlexRay, and Automotive Ethernet, right? So here we will be spending 2 days, 6 hours each on Saturday and Sunday, and we'll try to cover these protocols in detail, and we'll try to understand how does these 3 protocols kind of play a role, where the shortcomings of CAN are coming, right? So when we look at the LIN, it is a very low cost protocol, and yeah, it is something which can be configured very quickly, because we have a master which is having a the stack, whereas the LIN does not have any stack in or the software, right? It is just a single register which needs to be configured. We'll also understand the FlexRay, how it can act like a backbone network and also can satisfy the real-time requirement. And it can also give you a dual channel, which is kind of a unique compared to any other protocol, right? And then we'll try to understand the Automotive Ethernet, which is something which is trending today, and a lot of people are adopting it due to the robustness, the reliability, and the speed what Automotive Ethernet can offer. All right, so let us go into the course detail. and try to understand what are the various topics we will be covering in each. Okay, so this is the FlexRay topic. So in the overview, we'll try to understand what is electronification of motor vehicles and how the motivation for FlexRay has come into that. Right, we'll try to understand what is this FlexRay consortium and how does the specification looks like and what are the details mentioned in that. And we'll also try to compare the CAN protocol with FlexRay, and we'll try to see what are the additional benefits FlexRay is bringing in. We'll try to understand the important topics which are like a brake by wire or the steer by wire, how the FlexRay is promising this brake by wire or a steer by wire with high reliability and also with the speed which can go up to 10 Mbps to 20 Mbps, and also with the redundant line, right? With the 10 Mbps we can have a redundant line. And we'll also try to understand the safety and the fault tolerance what FlexRay as a protocol is bringing in, right? And then we'll go into the FlexRay communication protocol itself. We'll try to understand how does the node controller and how does the FlexRay bus looks like, what is the physical medium or the channel on which it works, and what are the different voltage levels it follows, right? And what are the bus interface which is used, and what is this bus guardian, right? Which is something new what we have in the FlexRay compared to the CAN, what its role. So we'll be looking into all those aspects. Then we'll come to the FlexRay bus access. The way we have a CSMA CD in the CAN, similarly we have a hybrid combo here where we have a static slot and a static segment, which is more like a CAN protocol, and also we have a which is more like a TDMA, sorry, and we also have the dynamic segment which is more like a CAN, right, where any node can kind of arbitrate and win the slot and they can transmit. So we'll try to study this in comparison of a CAN and see what advantages it can bring in. Then we'll come to the framing, the header, payload, and the coding part. We'll do a detailed analysis and understanding of this different bits and bytes inside the FlexRay frame. We'll go to the synchronization, very important topic, right? How does the synchronization is achieved inside the FlexRay protocol, right? What is the basic principle of synchronization which is used in the FlexRay, right? And then probably we'll go into the Kano and Canalizer tool using the FlexRay database, understanding how do we load it, how do we write a CAPL script using which we can interact with the FlexRay frames and we can send a different information over the Kano using a IG block. And we'll also write a CAPL script where we can do a start stop and create a simple GUI and send and receive some frames. And how do we access the static part of a FlexRay, and how do we access the dynamic part of the FlexRay? So that would be our focus when we come to the CAPL part for the FlexRay. Right. And also one more important topic which I think I kind of missed to explain is the after completing the every module, right, we will have a test or the evaluations which is something which is compulsory for each participant to take up, and also there would be hands-on assignments where they can work on it and which will be evaluated. So at the end of each module we will evaluate and we'll try to understand where the participant stands, and if we see that there is any gap in terms of knowledge acquisition, we'll try to address that with an additional effort. Coming to LIN protocol, which is a local interconnect. So here the focus is to understand why do we need this basic serial bus system, right? When we have already FlexRay or CAN in place, what is the advantage or the low cost part or the quick configuration which is bringing in? the fundamentals of the LIN protocols, which talks about the synchronizations or the secure data transmission, the frame slot, the scheduling part, or the network and the status management. We will go through that. We'll try to understand what is this LDF file, LIN description file, which is equivalent to CAN-DB in CAN protocol or the 5x file in the FlexRay protocol. We'll try to understand how the LIN network configuration works, right? What is this node capability file and how does it work, right? We'll try to understand the LIN hardware itself, the hardware interface. When I mean, how does the UART or the LIN UART or the LIN controller and the LIN transceiver, right? How they interact. And again, we'll come back to the Kano or the canalizer for the LIN, and we'll try to repeat the same exercises what we did for CAN or the FlexRay, right? How do we send, receive the frames, right? How do we use the IG block? How do we use the graphical user interface? How do we use the CAPL programming to access, right? We will do the measurement and analysis and the simulation and the emulation, both of it, and try to create some exercises and the assignments which you guys can perform over it. And there are extended functionalities inside the Kano tool itself, where we talk about the cluster simulation, the diagnostics messages, right? And how can we schedule unconditional messages, right? How do we do this lint stress test, the feature set test, right? So all of this would be covered in the last sessions, right? Which are slightly advanced topic. Next, we will look into automotive Ethernet. Yeah, so automotive Ethernet, we'll try to understand. First thing is, why do we need the automotive Ethernet, right? So we already studied kind of a 3 protocol, CAN, LIN, and FlexRay. So now what is the need for this automotive Ethernet, right? So it is bringing this enormous high bandwidth, which can go up to 1 Gbps, right? Which is the biggest advantage. And also this is a protocol which has been there for some time and it has proven its ability of robustness, right? The reliability part. So that is where the automotive industry is first time going out and trying to adapt a protocol which is already being proven its efficiency, reliability, right, and the robustness. So here we'll try to basically understand how this automotive Ethernet is different from a traditional Ethernet, and what is the motivation or the necessity of this automotive Ethernet in the automotive industry, and what are its different use cases, right? And then we'll get into the physical layer. We will try to understand what are the different topologies of the network architectures used, and what are the different T bases we have: 100 base T1, 100 base TX, and 1000 base T, which is our Gbps, 1 Gbps network, right? And then we'll get into the MAC, VLAN, and the Internet protocol, which is the IPv4 and the IPv6. And there are various, the once we have the physical layer covered, then comes our intermediate layers, which can be either IPv4, IPv6, or AVB. So it keeps changing based on what purpose or the use case we are gonna cover. So in this use case, we are gonna cover the MAC and the VLAN, which is which is used with the IPv4 or the IPv6, right? So we will study both the version 4 and the version 6, and we'll also try to understand what is the routing, right? What is the subnet mask? What is the ARP and DHCP? How does it work, right? And the complete the Ethernet frame, bus access methods, right? Addressing of the IP packet. So all this would be studied. We'll get into the switches and VLANs, how these are defined and what are its operations, right? What are the different modes in which switch can operate and how the switches are interconnected, right? And then we'll get into the TCP/UP, TCP/IP and UDP protocol, right? Which are the two predominant protocols which are always used, most of the time used against the IP itself, or the IP. Sorry, I meant the Ethernet protocol itself, right? And how they are structured, right, in the TCP and the UDP packets, how they are structured, and how does this connection oriented and connection less communication happens using this TCP and UDP. We'll also try to understand some of the other protocols which can sit on top of the Ethernet protocol, Ethernet physical layer, right? So we have some IP, which is a service oriented communication, right? So this is something which is becoming very popular, and this is also something which is already supported inside the AUTOSAR protocol. So we study about the serialization, right? The service discovery, remote procedure call. How do we do this publish and subscribe, right? And the segmentation of the different UDP messages, right? So we'll go over very quickly on the some IP part, and we'll glance on the AVB part, which is the your audio video bridging, right? Which is a one of the time synchronized data transmission, right? Which has got a lot of popularity once the automotive Ethernet has kind of entered into the automotive. So AVB is widely used when the audio and the video transmission comes, right? For the electric vehicle, we are going to use ISO 15118, which talks about the smart charging solutions for electric vehicle. We are also going to talk about the XCP. So we had like a CCP when you perform it on the CAN protocol, or you can have a FlexRay based communication protocol, right? So similarly, you have this XCP, which is a universal measurement and the calibration protocol, which is running on top of your Ethernet. We also try to understand how a diagnostic can be performed over a IP, which is called as a DOIP, famously, right? And then we'll try to get an understanding of AUTOSAR, Automotive Ethernet, right? How the entire topic, what we discussed, right? The Ethernet transceiver, the switch driver, the interface, how they are placed in a AUTOSAR stack, right? We'll try to understand that, including even the TCP/IP and the socket adapter. All right, and then the next layers of protocol, what we discuss: service recovery, some IP, right? UDP network management, so DOIP, XCP, so how they are kind of placed inside the AUTOSAR. We also have the V2G and the AVB modules. We will try to go over that. Then again, we'll come back to the Kano tool and we'll try to do the configuration, setup, simulation, right, measurement, and we'll also do the graphical user interface and the CAPL programming, which would be our hands-on part, where we write a CAPL program to control, receive, send different Ethernet messages. Okay, so let's come back to the original schedule. Yeah, so once we cover the three protocols, LIN, FlexRay, and the Automotive Ethernet, I think once we go through the CAN protocol, it would be fairly easy for you to follow up what is LIN, FlexRay, and Automotive Ethernet. All the basics which are required for to cover this advanced protocol would be covered in the CAN protocol, which in turn means the CAN is the prerequisite for LIN, FlexRay, and Automotive Ethernet, right? So totally we will be spending 12 hours on these topics. Then we'll come to the next topic, which is mostly the next layer of the stack, which is the diagnostics, which is the UDS, right? Here the focus is to so first let us look at the schedule. So we will be starting it on 5th of April. So we will have 2 weekends where we will do a full day sessions, and then we will have 3 weekday sessions of 4 hours each, right? So here focus is to go over each and every service of the ISO 14229 and try to understand the complete depth of service request and response, right? And then we will try to do a hands-on session of the same using the Kano and the CAPL scripting. So let us get into the course outline. Yeah. So if you look at the UDS part, so the focus is to cover the ISO 14229, the diagnostics and the communication management services. So we differentiate these services into different kind of groups. One is the data transmission, one is the stored data transmission, and then we talk about the diagnostic fault codes and the remote activation of different routines, IO control services, upload and download services, which are specially responsible for flashing the ECU, which is a software update. And then we will try to compare a UDS with the KWP 2000 protocol, and also maybe we can try to compare with the OBD protocol. So here the focus is to cover all the various services which are listed here, and we'll also be doing a implementation of the some of the important services like maybe security access, diagnostic session control, right? We can do read data by identifier, write data by identifier, right? RDTC surveys, reset surveys, right? So we will be implementing some of the very important services either on the C programming platform or on the CAPL programming, right? So that would be our key focus here. And the other thing what we can actually try to implement is the CAN transport protocol. So because the diagnostics runs on top of the CAN TP, so we can also try to use the previously written CAN TP implementation and try to bring in here and attach it and build the put a diagnostic stack on top of it. And yeah, we'll also get into the CAN OE tool itself, where we'll try to understand different send options. How do we do the data logging? How do we do the offline analysis of a diagnostic data which is already being recorded, right? How do we do the measurement analysis with filter, right? Having a different blocks of the measurements of the data flows, right? How do we create a reply block, right? Every time you get a request, how do we reply back using the reply blocks, right? We'll also try to understand what are the different signal server concepts, right, in the interaction layer, right? How can we make use of the CAN DBC file and the CDD file when it comes to the diagnostic part, right? Then we will do a detailed study of CAPL programming, right? Going through each and every aspect of the programming language, starting from the CAPL keywords, data types, declaration, right? So this falls in line with the our C programming. Most of the topics can be kind of reused here. It is almost stands similar to the C programming, but we'll try to understand what is the difference, how does the syntax looks, right? And how can we compile it using the CAPL browser, and how can we reuse inside the CANOE. So all of that topic is listed here. I'll not go in deep, but maybe you can pause the video and you can always take a look what are the different topics mentioned here. All right, so our ultimate goal is to kind of create a different network emulation, node emulation, right? And how can we do this CAPL application development, right? We will write some examples inside the CAPL. We will see how the periodic message transmission can be done, how the event handling can be done, right? We'll try to understand that, and we'll be building a product or maybe a example using a CAPL, and maybe we can also interact it with the Python using the com server part of the Kano tool, right? And we can create a graphical user interface, and we can build, I'll just show you an example. We can build something like this, which is a cluster which consumes information from an engine, right? It can also consume the information from the clutch pedal, brake pedal, accelerator pedal. So we'll be building something like this once we have the knowledge of CAN TP, the Kano CAPL programming. So we can build up the complete a product kind of a look and feel inside the Kano panel designer. Okay. So let me get back to the next topic in the schedule. Yeah, so the next topic we will have is the AUTOSAR. So now all these topics becomes a prerequisite for the AUTOSAR. So AUTOSAR is going to be complete 24 hours training, right? So in the AUTOSAR, we will try to mainly look into the 3 stacks, which is our DAG stack, communication stack, and MEM stack. So these are the predominant stack where our key focus will be given, but that doesn't mean that we will not study other modules. We will be studying definitely every module which has been sent in the AUTOSAR 4.4. including the crypto stack, including the wireless stack, right? And totally we will be spending 24 hours of time with 2 weekends, 8 hours, and weekdays 4 hours. And we'll try to complete this course by 19th of May, right? So it's closely 1 month of an effort what we'll be putting if you opt for all the courses, right? And yeah, let us go into the AUTOSAR content itself and try to understand how does that look, right? Yeah. So yeah, if you come here, you'll see the AUTOSAR content, right? Where we will try to understand from basics what is the overview, all right? What is the goal of the AUTOSAR? Why do we need this AUTOSAR layered architecture? Uh, what is the basics and the fundamentals of the AutoVar? What from where the motivation has come to come up with the AUTOSAR as an architecture, right? And what are the different configuration classes, right? We'll try to understand a very high level architecture in terms of com stack, mem stack, RTE, right? Communication manager. So all of these topics we'll try to study it from the very high level to get a feel of how the entire architecture is placed. And then we'll come into the methodology where how does the input description file looks like, how does the system configuration file looks like, what are the importance of these two files, what is the ECU configuration, and how once one can extract this information or generate the software executables using this, right? We will try to see that. We'll also do a session on the runtime environment where we'll try to understand what is RTE, how it is related to virtual function bus, right? How this RTE can be kind of generated using a RTE generator. What are the key features and how does the portability of RTE works, right? So all of that we will try to understand. Then we'll get into the complete BSW, which is the majority of the AUTOSAR, right? Where we will go into each and every layer and each and every module, right? For example, if you look at here, service layer, right? In the system services, we'll be going through all the modules which are listed under system services, which could be com manager or BSW mode manager, crypto service manager, issue state manager, right? So your watchdog manager, your synchronized time-based manager. So all those manager modules which are sitting in the system services, we will be covering through that. Similarly, diagnostics, once you complete the diagnostic modules, you'll be able to relate what is DEM, DET, DLT, what is this FIM, right? So similarly, memory services, non-volatile memory, communication services. Here we cover all the CAN, Ethernet, FlexRay, LIN, right? And all the other common modules like a PDU router and debugging modules. Then we come to the ECU abstraction layer. Again, here in the abstraction, it would be the interface which we'll be covering. Again, for CAN, Ethernet, Flex, LIN, you can see the interface and the transceiver part, what would be focused here. And similarly for the memory, it will the memory interface for the EEPROM and for the flash, whichever memory we are going to use for the project. And then we discuss about the complex driver, why it is required, what is the importance of it, right? And how you can write your own complex device drivers. And then we come to the MCAL. We'll try to understand what are the different drivers which are standardized by the AUTOSAR. Right here, we'll again go through all the communication drivers, all the IO drivers, right? All the memory drivers, all the microcontroller drivers. So once we cover all the different drivers, then we try to look and stitch all of this together, and we call it as a stack, right? So we'll try to see the entire com stack in the picture, right? Starting from the CAN driver till the PDU router, how the message flow happens. If it is a diagnostic message, how the DEM, DET, or the FIM will react with that, right? How the DCM is split into DSP, DST, DSL, and how they are going to interact with each other, right? Similarly, the mem stack, how the non-volatile information would be stored, what is uh, the memory interface or the NVRAM manager's role to play here, right? Is what is the redundant blocks, how does the data sets are stored, right? So all of these three stacks we'll be studying in detail, right? Once we complete the individual module, and we'll also look at the peripherals and some safety and the security related features, right? And then we'll get into the DaVinci tool itself, where we'll do a very deep dive study of understanding from basic what is the SIP, what is the ARXML file, how do we create a new project, how do we create a this loadable and selectable options, how do we do the pre-compile support, link time support, right? So all of these basics from scratch, even before even starting the configuration, right? How can we do all of that? Then we start with importing the different ARXMLs, right? And how do we configure the ports, pins, SPI, ADC? We'll not be leaving any modules. We'll try to configure each and every module which is available, right? PWM, DIO, DEM, CAN configuration, BSWM, ECUM, right? So all these different modules we'll try to cover, and we'll try to build a CAN stack or a MEM stack or a DAG stack, and we'll try to generate a code using the DaVinci configurator, right? We'll also have a lot of demo and assignments, right? Where you can witness how it happens, and then you can do it by yourself. Every individual participant will get an access to a system where all the required tools will be present on that particular day of the training. Whichever is required, it will be available for the participant. Then we'll again, as usual, as we are doing for every module, we will end the AUTOSAR session with the uh, uh, a test followed by a hands-on test, right, where we can evaluate again what is the penetration level of information. If we feel any participant needs an additional support, definitely we can do that. So that completes the complete course outline, right? So if you look at the entire course, it is around 80 hours of a course. Based on which topic you feel you want to opt, you can opt that. And if you're someone who is gonna go for the entire course, which is of 80 hours, you are gonna get a 20 hours bonus live Q&A support, where we will be helping the participant with an additional question answer session. Once you learn all this topic and go back and try to apply, definitely you'll have a lot of doubt, and we don't want to leave you alone there. We will have this additional 20 hours on the regular basis, where all of us can meet and discuss what are the different challenges you guys are facing and how do we resolve it, or any of the topics which you have doubts. Maybe after rereading or going through it, you are coming up with a new scenarios or the situations you don't know how to handle it, right? So we can discuss all of that, and this is only available for the participant who opt for the entire 80 hours program. And the AutoVerse certified professional, right? So this certification will be given for the only participant who opt for the entire program. And it is not the participation certification, but it is the a certification which says that you have cleared all the evaluation tests and all the practical tests, right? So our intention is here is not to just focus on completing the training, but also to ensure that each and every participant who is attending this training gets the required knowledge, and he's confident from the day one that he can go to the project and he can start contributing. And if anybody who reaches that level and who clears all the tests and all the practicals, he will be handed over this AutoVerse certified professional certificate, right? You can take a look at how the certificate looks like. It's just a sample certificate, and what are the technologies you will be trained on. So all of that is kind of listed here.